Welcome to the ARDMS SPI review, Introduction, Part 2. Today we are going to talk about measurement units, pulse echo techniques, and the 13th microsecond rule. This is my website, ultrasoundphysicstutor.com. I offer complete ARDMS SPI review. My review includes semi-interactive console questions. My contact information is samiki098@gmail.com and my phone number is 713-392-4624. Let's talk about length, area, and volume. All numerical values must have corresponding units attached. So for example, if I ask somebody how old is she, if they reply 3 doesn't make sense. Why? Because they might be 3 years old or 3 decades old or 3 weeks old. So always remember, whenever you're memorizing the formulas, you should always have the units memorized as well, because in the boards they ask you questions about units. A number without unit, it means little. Units of length is length of space between two points. Distance is equal to centimeters, millimeters, and feet. Units of area is number of unit squares contained within a flat plane is centimeters square and feet square. Units of volume is amount of space occupied in three-dimensional, so it is centimeter cubed and feet cubed. They have asked this and the unit of volume in the board, so please memorize these. These I call them no-brainer questions. So some more important concepts: increase by the factor of, product of a number means to multiply, decrease by a factor of, or means to divide. How are images created in ultrasound? Ultrasound images are created using the pulse echo technique. So what the transducer does is, when you put the transducer on the patient, it generates a pulse of sound. The sound travels into the patient. The echoes are produced at boundaries of organs and within tissues. Echoes return to the transducers, and the echoes are detected, processed, and recorded. So here, ultrasound is not only is used for diagnostic purposes. They use ultrasound to determine the depth of oceans or find missing objects in oceans, and they have various rules. So let's see what we said. We said that the transducer generates a pulse of sound. That pulse of sound goes into the patient, and then the echo comes back, and with this echo they generate millions of dots over here, and these millions of dots join together to make an ultrasound image. Now again, strong reflector is a bright echo, or it means echogenic. Weak reflection means a dark dot, and it means anechoic. So pulse echo techniques: ultrasound instrument processes the information received and generates dots. These dots make the image on the monitor. Deeper the dot, deeper is the organ. If the dot is placed at a shallower, the part of the organ is shallower. Brightness of the dot corresponds to the strength of the reflectors. Like we said, if it's a bright dot, it means that it's a strong reflector, for example, bone. And if it's a dark dot, then it is something like a fluid, which is anechoic. So how does the machine calculate the distance? It uses the same distance formula as we would. So by knowing the direction of US ultrasound pulse when it enters the soft tissue of the patient, by knowing the appropriate distance, it uses the distance equation, which is rate of speed times time of travel. So here's an example. If a boat is traveling at 25 miles per hour, how many miles will it travel in 3 hours? So we just simply multiply rate, which is 25 miles per hour, times hour, which is 75 miles per hour. So our ultrasound machine is programmed for a little bit modified distance equation. It is called the range equation. Range, always remember whenever they talk about range in ultrasound, they're talking about depth. So it's the depth or the distance equation. The machine determines at what depth to place the dot by this range equation. Range is equal to speed times time divided by 2. Now where did this 2 come from? Yes, it is the go return time. So the ultrasound goes into the patient and then it comes back. So some important concepts. In soft tissue, sound travels at 1540 meters per second or 1.54 millimeters per microseconds, or it is the 13th microsecond rule, or it takes 13 microseconds for sound to travel 1 centimeter and back. In soft tissue, I call it the Friday the 13th rule. So let's discuss a little bit about this rule, 13th microsecond rule. This 1540 meters per second, make sure you know the units, because they'll give this in your boards and they'll change the unit around. Or 1.54 millimeters per microsecond, they'll put centimeters per milliseconds or something like that. So make sure you know the units with this. So let's talk about 13th microsecond rule. So we said the 13th microsecond rule was it takes 13 microseconds for sound to travel 1 centimeter and back. So how long will it take for it to travel 2 centimeter and back? We'll say 13 times 2 is equal to 26 microseconds. How long does it take for it to travel 3 centimeter and back? You'll say 13 times 3 is equal to 39 microseconds. Now, how long will it take to travel 1 centimeter? You'll sometimes you hurriedly just say 13 microseconds, which is incorrect. Why? Because I did not say back. I was just talking about one-way trip. So for one way, it's going to be 13 microseconds divided by 2, which is equal to 6.5 microseconds. So here is my website. Again, I offer complete ARDMS SPI review. My review includes semi-interactive console questions. My website is ultrasoundphysicstutor.com, and here is my information. Thank you for watching. Please like and subscribe my video for so you'll get more updated information.